Hey kiddos, it is Miss Lloyd, and we are looking at the tangent, cotangent, secant, and cosecant functions and how to graph them. So when it comes to a tangent function, I'm looking at all of the pretty points for tangent in the unit circle. So those are as follows. And so for these, I do have to worry about when the tangent function is undefined. So this is when our cosine is equal to 0 because it's sine over cosine and we can't divide by 0. So in these places here where I have undefined, I'm going to be putting asymptotes. The same way we do whenever we have our rational functions. So those functions where we have variables in the denominator. And then these also repeat on the other side. Since our negative pi over 2 is in the same place as 3 pi over 2, they'll have the same asymptotes. Same with pi over 2 and negative 3 pi over 2. Now I can put my pretty points down. And so here we can notice that I have quite a few of these little worms that make up our tangent function, and they are 1 pi long. So I went from negative pi over 2 to positive pi over 2, so that's an entire pi. So this is how long our period is. That's how long until our tangent function starts to repeat itself again. And so with cotangent, because it's the reciprocal of tangent, I'm just taking all of those functions and flipping them. So where I have 0 for my tangent, that's going to become undefined for my cotangent because it's like 0 over 1. Anywhere I have undefined for my tangent, that's actually going to become 0. So remember, sine over cosine for tangent now becomes cosine over sine for our cotangent. And so anywhere where my sine would be 0, I now have undefined for my cotangent. And so again, what I like to do is draw out those asymptotes first, so where my cotangent is undefined. This is another case where my p is going to be pi. And so here you have your cotangent function. So these next two, my secant and cosecant, I again have to remember what their reciprocals are. So for secant, this is the reciprocal of cosine, so 1 over cosine theta. So what I like to do when I start my secant function is to graph the dots for my cosine function. So I know cosine starts at 1, goes to 0, negative 1, 0, and 1 again, and then repeats that process on the other side. And so because I would be flipping the function, anytime I'm crossing the x-axis, so anytime we would have 0 for our cosine of theta, I'm going to put an asymptote because technically it would be like 0 over 1, and then I would be flipping it to 1 over 0. So these all become asymptotes. My other points here are going to remain. And what they're going to do, so whenever I end up with, let's say, pi over 4 of cosine is going to be square root 2 over 2, which means that the sine is going to be just square root 2. The secant is going to be just square root 2, which is larger than square root 2 over 2. So what happens for these, if we were to graph out or plug in numbers, we end up creating this parabola-looking function. It is not a parabola, but it kind of looks like one, this U shape that goes up. It starts getting closer and closer to those asymptotes, but it's never actually going to touch them. And then same with the ones that are below the x-axis. These are just going to point downwards because they're negative. And there we have our secant functions. And we're going to do the same thing for cosecant. I know cosecant is the reciprocal of my sine, and so I'm going to be working through all of this with the sine function, the same way I did with the cosine. So I'm going to graph the main points of my sine function first. I'm going to put asymptotes through the places where I am crossing the x-axis. And then each of these points that are not on the x-axis, I'm going to create those U-shapes. Hopefully y'all aren't judging my U-shapes at this moment. And so when we're graphing these, we do want to be careful with those asymptotes. It's where our denominators are equal to 0. So for tangent, it's always going to be when cosine would be 0, for cotangent when sine is 0. And then similarly for the inverses, anytime the reciprocals, anytime the reciprocal is going to be 0, that function is going to have an asymptote. I'm going to save the rest of the examples and whatnot for my students. I hope you found this helpful. If you did, please like and subscribe. And if you think this could be helpful for someone else, please feel free to share it. Spread the love.